Hey, hi guys, welcome back to 360DigiTMG's Domain Analytics program. And yeah, this is the third day of Domain Analytics. We have discussed about what are the CRISP-ML methodologies and what are the applications we'll be having. Sorry, it is the fourth day of Domain Analytics program. And we have discussed the CRISP-ML methodologies. And then we have discussed about the applications when it comes to banking and insurance. So what exactly we'll be using the machine learning or AI when it comes to banking and insurance, and how things will change when you use machine learning when it comes to insurance and banking that we have seen, and then whatever the anomalies we'll be having in our data. So how can we remove those? So what are the various techniques we'll be having? Like we have seen duplication. If you have a duplicate data in your data frame, duplicate entries you can say, and extreme values. That is also calling it as outliers. So we will be finding out those outliers using the box plot. So yesterday we have done the coding as well to do the visualizations, and we have done EDA, exploratory data analysis. In that we have first movement business decision and second movement business decision, third and fourth. So it is mean, median, and mode. Combining all these, we will be calling it as first movement business decision, and then we have spread of the data. So dispersion, standard deviation that are part of the second movement business decision, and then we have seen skewness. To measure the symmetry of the data, we will be going with third movement business decision, that also called as skewness. And then peakiness of the data to understand how many products, which are the products most number of times or most frequently getting sold. In that case, we will be having kurtosis. So like that, what are the pre-processing techniques we'll be having? What are the EDA, exploratory data analysis, that we have discussed in the previous session, that is third day of domain analytics. And today we will be taking unsupervised learning. Unsupervised learning. So what exactly is unsupervised learning? What is the supervised learning that we have already discussed? If you haven't seen those videos, in that case, let me go through that briefly. Supervised, the data, whatever the data frame that you will be having, if you have a labeled data, in that case, we will be calling it as supervised. We will be going with supervised. So if you don't have a labeled data, if you don't have a labeled data, in that case, we will be going with unsupervised, right? So this already we have seen. So we will be going with unlabeled data. It is not labeled. It is not having any label, unlabeled data. In that case, we'll be going with unsupervised. So what is the label? The output. Let's say yesterday we have seen COVID. Various symptoms will be having and final status, whether you have a COVID positive or negative. So this we will be calling it as output. That is, we will be calling it as output, or you can say label. In that, we will be having various classes. Here we just have two classes, that is positive and negative. In that case, we will be calling it as binary classification. But that is a very different topic. When we are discussing classification, in that case, we'll go through all those things. Here we will be discussing about unsupervised. So what is unsupervised? When you don't have labeled data in your data frame. When you don't have a labeled column in your data frame, In that case, we'll be going with unsupervised. So what is unsupervised? What we will be doing in unsupervised, we'll simply make groups, especially when it comes to clusters. Clustering. So whatever the data we will be having, based on the similarity that are present in those data or the data points, we will be creating the clusters. So cluster 1, cluster, how many number of variety of data if you have, that many clusters we will be creating when it comes to unsupervised learning. It is not just, unsupervised learning, that doesn't mean only clusters. We will be having other association rules. That also comes under unsupervised. And we will be having network analytics. So that is also comes under unsupervised. So cluster is not the only unsupervised learning we are talking about. So yeah, without wasting any time, we'll see what is the agenda of this session and what are the topics we'll be covering in this session. So we have seen what is the CRISP-MLQ. Irrespective of any domain, we will be applying the CRISP-MLQ techniques. CRISP-MLQ. Irrespective of any domain, we will be applying the CRISP-MLQ in order to do the one project. So it is a sequence. So we have already seen when it comes to CRISP-MLQ methodology, business movement decisions will be having, right? Business management methodology, sorry. Business management methodology. So CRISP-MLQ means cross-industry standard process, machine learning quality assurance. So what are the phases we'll be having when it comes to whether it is unsupervised learning or supervised learning, anything, we will be following this CRISP-MLQ methodology. The very first one, we will be having business understanding. So we know what exactly we will be doing when it comes to business understanding. We'll try to understand problem statement, and using that problem statement, we will be coming up with business objective and business constraint. We will be coming up with business objectives and business constraint. Once it is done, if you know the business objective, in that case, we will be having an idea which are the features we will be considering. So for that, you need to have a data understanding. What data I have to collect? Which data I have to give more preference? So for that, you need to have a data understanding. Various data types will be having. And once it is done, we will be going with data pre-processing, obviously. So yesterday we have seen those data pre-processing techniques. If it is textual data, that is unstructured, you can say. In that case, we will be doing the different pre-processing. And if you have a numerical data, in that case, we will be doing the different pre-processing techniques. We have seen yesterday what are the numerical data pre-processing techniques we'll be having. When you have unstructured data, how we will be doing the pre-processing. So, and then we have done the few pre-processing techniques as well on the code, using the code. And it is done when you do know that when you clean the data. Once it is done, we will be going with model building and tuning. So what is model building? Whatever the data, clean data we will be having, we will be building the machine learning model. So we are training that machine learning model using the data. So when it is machine learning, in that case, we will be splitting the data into two that we have seen on the second day of domain analytics program. And here, if it is association, unsupervised, we can simply split the data based on those similarity. It will simply come up with the rules. Right, we have seen that, and then we will be deploying it. And once it is done, we will be monitoring that whole deployed model. So these are the Chris-Pemel methodologies we'll be having when it comes to data science. Any project, data science project, you will be following this Chris-Pemel methodologies. So once it is done, unsupervised learning that I have already discussed. Unsupervised learning is a machine learning technique in which models are not supervised using the training data set. So we are not training. It is not under the supervision of anything. So these are not trained. So directly we are feeding the machine learning algorithm and then you will be getting the rules. Based on those rules, we will be segregating into various categories. Instead, models themselves find a hidden patterns. So when you feed, once the pre-processing is done, when you feed the data to the machine learning model, what it will do? If you have any hidden patterns in the data, hidden insights from the given data, so it will simply come up with those insights compared to the learning which takes place in the human brain while you life. So normally, when you have a child, when you are a child, in that case, what you will be doing? You will be doing so many things in order to learn. What things you have to do, which things you are not supposed to do. Let's say, yeah, your mom told you to not to touch that hot plate when you are child. In that case, you won't be able to understand what is it. But when you touch it, you'll feel the pain. In that case, what happens next time? You won't touch that particular hot anything. So what you are doing here, you are learning. Similar to that, when you are childhood, normally when you given the lollipop, if you are watching that lollipop with the very first time, in that case, you won't be feel anything. But when you start, eating that, in that case, you will understand like, yeah, it is delicious. So in that case, what you'll be doing next time, if somebody, give you lollipops, immediately you will be taking it. This is how, when you are in childhood, you will be learning all those things. Right? Similar to that, machine learning model, we have to feed the data. In order to make machine learning learn, you have to give inputs, various inputs you have to give. Then only it will able to learn. So that you will be, this is how machine learning also getting trained. So you need to feed the lot of amount of data. In that case, it will learn those things. And when it comes to unsupervised, it will come up with the rules, various rules. Based on those rules, if you pass new data to that particular machine learning algorithm, it will simply tell which it belongs to. Whatever the data that you are getting. If we are going with the clusters, in that case, which cluster that particular data, whatever the data, new data that you have entered, it belongs to. So like that, you will come to know. The goal of the unsupervised learning is to find the underlying structure of the data set, that is inferences, hidden insights. That is what we will try to find out. And then whatever the resultant that you will be getting, that will be a clusters with low variance. Low variance means whatever the cluster that you are forming, variance means spread out the data from the mean, right? So here we have mean. How far the data is spread? Variance, how far it is spread. So if we have mean here, low variance means it should be density. The density should be high. That we will be calling it as good cluster. So these are all dense, and here one more cluster will be having, that is also dense, and one more cluster will be having dense. In that case, we can call it as a good clusters. The resultant group will have low variance clusters or groups, we can say. So this is the unsupervised learning, normally how it happens. Now we will see Among these unsupervised learning, K-means algorithm will be taking, and we'll see how this cluster will be formed when you have real-time data. So yeah, we'll look into that. Yeah. So below is the list of popular unsupervised learning algorithms. So K means it is unsupervised. It is popular, very popular unsupervised learning algorithm. And K-nearest, this one comes under Kmeans algorithm. And then we'll be having hierarchical clustering. We have anomaly detections, and we have principal component analysis, and we have independent component analysis, a priori algorithms, and singular value decomposition. So these all comes under unsupervised learning. These all comes under unsupervised learning. How it is done? How it will work? Let's say I'm giving raw data. So here, when it comes to supervised, we'll be having train. We will be training the machine learning model, and then we will be testing it. Here, we don't have that option. We will be simply supplying the features. So based on those features, based on those similarities, what it will do? It will simply categorize those into various clusters. So let's say one example, a small example we'll be taking. Mixture. So let's say one feature we have dog and one feature we have cat. Cat means various features will be having it. It will be size in between, like some size. Let's say X size to Z size. This much it will be growing. When it comes to cat, it will be like A and B. How much weight it will be having? So dogs can weigh up to from adult one I'm talking about, not from the babies, and various other features also will be having it. Dog will be something like that, and tail will be bit. So these are the features will be having it. Dog and cat features are very different. So those features only we are mentioning. Those features only you are mentioning in the data set. So this is one entry, and we'll be calling it as dog. This is one more entry. The features, various features we can mention, and we can call it as a cat. Various features, and again dog. Various features, again cat. Something like that we have. It is labeled data. Labeled data. But we don't have this data when it comes to unsupervised. Without this, based on these features only, we have to categorize those into various or cluster into various. So we will be giving inputs of all mixture data and their features. Using those features only, this algorithm, unsupervised algorithm, it will simply process that, and it is considered as categorized as two groups, that is dog and cats. Not just two, we can give multiple features, various features we can give. Based on those features, it will simply segregate into various clusters, or you can simply say various groups. And then unsupervised learning. So this is the process when it comes to unsupervised learning. First, data, the main data we will be having, right? We are simply historical data, you can simply say. We will simply pass through the machine learning algorithm. When you pass through the machine learning algorithm, what it will do? It is after pre-processing, guys. After cleaning the data. If you don't clean the data, in that case, so much mess will happen. So machine learning algorithm won't take those unclean data. So once it is clean, and then we will be passing through machine learning algorithm, and then what it will be based on the patterns. It will go through all the patterns, and then it will come up with rules, various rules. It will come up with various rules. So once it is done, you will be giving you new data. Same machine learning model, we will be giving new data, based on the data features, what it will do, it will simply says that which cluster it belongs to. We have created right here dog cluster and cat cluster. If you are giving features, whatever the features on whichever the features we have trained the machine learning model, same feature we are giving as an input. So what it will happen? It will simply go through that, and based on the rules, whatever the rules we have created for in order to being a dog. So what are the features it should follow? In order to being a cat group, clusters I'm talking about. In order to being a this cluster, what are the features it is supposed to have? In order to become a in order to be in a dog cluster or cat cluster, what are the features? Different features will be having it, not exact features will be having. If you have exact features, in that case, all will be in just one group. But dog and cat will be having very different features. So based on those features, we will simply say that it belongs to the cat, cluster, and it belongs to dog cluster. Based on whatever the inputs that you are giving, whatever the features that are present, we are simply segregated into two groups, that is one cat and one more dog. So this is the unsupervised learning. So like I said earlier, we will be discussing any one of these unsupervised learning algorithms. Unlabeled data. So we don't have any labels. And here we have just given the features. No label. I'm not saying this is a cat, it is a dog, it is a cat, dog. If you say that it is a labeled one. So I'm not saying that is the labeled one. Let's say I have introduced one more. We have cat, dog, and we have a duck. So these are the features of those. Based on the features it will be having, we are simply classified into various clusters. So it belongs to the cat. Maybe it is belong to dog, and it is belong to duck. So like that, we will be having various cluster will be various data, we can say. Various data will be segregated into different clusters. So based on the features, how we will be finding out those features? Based on what we are finding the similarity. How we are finding the similarity, those all these things we will discuss now. We'll see now. So in unsupervised learning, we have very popular algorithm, that is K-means clustering. In unsupervised, we have very popular one, that is K-means clustering. What exactly the K-means clustering is, and when we are supposed to use those K-means clustering, we will go through that. K-means is one such unsupervised learning method that aims to group similar data points in a cluster. So what are these similar data points? How it will come up with these are the similar data points and these are not. We will see now in detail. So when you are giving data inputs, we have seen, right? Here you can see. So we have given inputs. These are the data points, and these are the data points, and these are. Based on the similarity, it will simply group it. So all are near. So it might be similar. Based on the distance, we are calculating the similarity. That is the reason. If it is near, in that case, it is similar. It is near, in that case, it is similar. Is it near to this? No. So whatever the near data will be having, it will consider as it is similar. And then we'll simply groups into various groups or clusters. It allows us to cluster the data into different groups, and a convenient way to discover the categories of groups in unlabeled data set on its own without need of any training. We won't be doing any training. We are simply passing that into the machine learning algorithms based on the patterns that are there in that particular data. It will simply go through it and it will find out the similar patterns, or it will find out the similar features. Based on those features, how many number of groups it can be possible, that many groups it will be creating. And then if you want to change it and if you want to customize those groups, the number of cluster that you will be having, you can do that. But it should be whatever the cluster it is forming, it should be feasible, or it should be all the cluster, all the data that is present in individual cluster, it should be similar. Then only that cluster will be making sense. Low variance, whatever the cluster that we are forming, it should be having the low variance. Then only we will be taking the data into the consideration. It is a centroid based algorithm. So what exactly the centroid is? The mean of all the clusters, we will be calling it as centroid, where each cluster is associated with the centroid. So here one cluster, one centroid will be having here one more cluster, one centroid will be having here one more cluster, will be having one more centroid. So these clusters are associated with the centroid. So that is the mean. We'll be calling it as mean. Centroid is mean here. The main aim of this algorithm to minimize the sum of the distance between the data point and the corresponding cluster. Density, we are supposed to take density. Less distance, in that case, more similarity. So that is what we are talking about. Yeah. So how it is happening? So how does Kmeans algorithm work? What is the process? That we will see now. Yeah. So how it is works, the Kmeans algorithm. Now we will see. So first of all, whatever the data we'll be having, we'll simply pass centroids upfront. K value we have to pass. Minimum 2. Since cluster we need to have at least 2, or you can pass 3, 4, 5, anything. Any number of cluster you can form, you can pass, but upfront we have to pass. Upfront you have to pass those clusters. When you pass those clusters, let's say this is my data. Let's say this is my data frame. So these are all, each and every data will be having with respective features will be having. Then only it will be coming under. Let's say dog. So dog feature data it is. Cat feature data it is. So feature, each and every data point will be having respected features. So let's say something like that we have. And there is one more. So now I'm upfront passing k is equal to 3. I'm giving k is equal to 3 clusters. So what happens when you give k is equal to 3? Randomly 3 centroids will be created. Where exactly it will be created? No idea. Randomly it will create anywhere. It could be here, it could be here, it could be here, it could be here. So here, let's say here it is centroid. 3 centroids. Since you have passed through centroids, 3 centroids have been created. So once the centroid is created, what it will do? It will find out the distance between each and every data point. It will find out the distance between each and every data point. So here. It will find out the distance between each and every data point. Similar to that, this centroid will be having that. It is also do the same. It will be finding out the distance between each and every centroid, say in each and every data. So like that, you'll be finding the distance between each and every data point. Same thing it will happens here as well. Same thing happens here as well. So whatever the centroid that we have given, from that each and every data point that is present, the distance will be calculated. Once the distance is calculated, then whichever the shortest distance we will be having, it simply form one cluster. Like that, it will be class, forming one cluster. Whatever the near distance will be having, that is, it is one cluster. Here it is one more cluster. Here one more cluster will be having. Like that, clusters will be created. Since we have given three, in that case, three clusters will be created. So once cluster is created, what we will do? Let's say here we will be having that centroid. Centroid here we have, and here we have. Once the cluster is formed, we will be finding the average, that is mean or mean. Mean of those all the clusters distance will be having it. Mean of the all the cluster distance will be calculating. Once the distance mean is calculated, the average is calculated. This data we will be having it. It will simply move that center to the mean, a new mean. Once cluster mean is calculated, it will simply move from this data to this. Same here, it will calculate the mean. Mean will be maximum, it will be in the middle, right? So it will simply move that centroid from the random centroid it is created, right? It will simply move to the actual. The new mean, it will simply, again, it will calculate the distance between each and every data point that is present. And again, based on that, again, it will, shift that mean again and again until and unless it will settle down. Until and unless there is no movement in centroid. There is no movement in centroid. It will keep happening. So if its centroid is constant, in that case, whatever the cluster that we have found are the best clusters. So this is what we have explained here. Initialize the centroid K. For each sample in the set of the samples, assign sample to its closest cluster K based on the Euclidean distance. So here, in order to find out the distance we are talking about, right? How it is calculated the distance based on Euclidean distance. What is the Euclidean distance? X2 minus, when you have two data points, how can we find out the distance? So this is the Euclidean distance. When you have just two, when you have numerous, in that case it will keep going on. The list is keep going on. Like that, we will be finding out the distance. Using what? Euclidean distance. Using Euclidean distance, we will be finding out the distance. For each cluster in the set of cluster, recalculate the cluster centroid based on the mean of the samples in the clusters. Whatever the clusters will be having that particular cluster, we will be calculating the mean. Based on the means, whatever the random centroid we have formed, right, it will simply move to the new mean. It will keep happening. Repeat this 2 and 3 steps until stopping criteria is fulfilled. So until and unless it will stop, you can keep repeating that. Determine the variance of each cluster and sum of the squares of errors. So we'll be finding out error, how variance is, how much variance we'll be having. The less variance, in that case, we'll be having the best clusters, right? So we'll be finding out that. Repeat 1 and 5. Initialize the cluster again. Again, it will go on until and unless there is no movement in the data or no movement in the centroid. So this is how K-means will be working. This is how K-means algorithm will work. So if you want to see that animations, in that case, let me show you that animation. You can see here. So here we have given 4 centroids. So what it will be doing? See how it is creating the clusters. So when you give 4 centroids, so randomly we have given k value is equal to 4. K value is equal to 4 we have given. So in that case, what happened? Randomly centroid, 4 centroids will be created. Once it is done, it will keep moving. So it will find out the distance between each and every data point. It will be finding each and every data points. It will be finding all the data points. Based on the nearest distance, it will simply create one cluster. Like that, it will keep happening until and unless there is no movement of these centroids. So you can see here. So how it is calculating. So it is all comes under one cluster, and then it will be calculating the mean, and based on that mean, it will be moving. So here it is finding the clusters mean. In that case, it is moving. So again, it is finding out the cluster mean, and then it is moving. Like that, it will keep happening. See how those clusters, centroids are moving. How those cluster centroids are moving. So previously, here it is, and then finally it reached this table. So this is one cluster, and that is one cluster. Like that, we will be creating the clusters. So for clustering, we have agglomerative clustering, we have density-based clustering, why K-means clustering. And what happens, there is any drawbacks when it comes to hierarchical clustering. Hierarchical clustering also we will be having. Why not be going with hierarchical clustering? Why just K-means clustering? What are the advantages we will be having when it comes to K-means clustering? That we will see. A K-means clustering algorithm used for the group unlabeled data set instances into cluster based on similar attributes. So what exactly that means? Based on the similarity that is present in our data point. What we will be doing, we are simply converting into the various groups using what? K-means clustering. K-means is the most used clustering method largely due to the being computationally inexpensive. What exactly we are doing? We are not doing anything other than calculating the distance. So that is what? Euclidean distance. We are calculating the Euclidean distance. Other than that, we are not doing anything. So that is the reason computationally very inexpensive. It is not expensive at all. That is the reason we will be using K-means clustering. It can scale well with this large data. When it comes to hierarchical clustering. So when you have a large amount of data, it is won't be able to process. And it will be taking a lot of time to create those dendrograms. So dendrograms will be having when it comes to hierarchical clustering. What it will be doing in dendrograms? It will simply form clusters. See, various data frames will be having, it will simply, based on the similarity, it will be creating the dendrogram. So when you have a small amount of data, in that case, you can able to, in order to tell how many number of clusters are making sense from the data, we have to look at the dendrogram, and then only we will be able to say that, yeah, these many clusters are making sense when it comes to this data. When it is having a small amount of data, when you have a small amount of data, in that case, it is feasible. But when you have a large amount of data, it will take a lot of time to process, as well as it is, you won't be able to see those dendrograms at all. It will be clumsy. So it is, all the dendrograms that you will be having, it all are overlapped. So in that case, you won't be able to observe it clearly. So In that case, we won't be able to say that whether how many number of clusters are making sense. That is the reason we will be going with K-means clustering. It scale with the large amount of data. So when you have a large amount of data, in that case, we can easily able to find out how many number of clusters are making sense. It is an appropriate method when you know. So normally K value, who will be deciding this K value? Upfront, we have to give these values, right? How do we know how much K value we have to give? So if we don't know any domain knowledge, let's say we are working on some particular domain. Since we are working on the banking now, so if we have a banking knowledge, so if you want to categorize into some categories, I want to group them into just 2 categories. I want to group them into just 3 categories. In that case, upfront you can be able to give K is equal to 2. I want just K is equal to 3. When you can able to do that, when you are proficient when it comes to that particular domain. Whatever the data that you're working on, if you are familiar with that particular data, in that case, you can be able to give what exactly the K value upfront you can able to give. So if you know how much K value you have to give upfront, in that case, it is the most appropriate data, most appropriate algorithm. It is when you know K value, cluster, how many number of clusters are making sense upfront, if you know, in that case, you can easily able to do that. And speed, when it comes to hierarchical clustering, it will take a lot of time to load those dendrogram. But when it comes to K-mean, it won't take any time. Immediately they will be giving results. Compared to the hierarchical clustering, it will way better than hierarchical clustering because it will be giving you results immediately. When you have a large amount of data, it will take a lot of time to load when it comes to hierarchical clustering. So these are the advantages we'll be having over other clustering techniques. So limitation, what are the limitations? When you have advantages, we'll be having some limitations as well, right? If you know that domain, that particular domain, whatever the domain you are working on, if you know that, in that case, we can use K value upfront. But if you don't know, in that case, what value we can give? So you have to do iterations, 2, you have to give 3, you have to give 4, you have to do various iterations you have to do. And then whatever the variance, cluster variance we are getting, based on that, we will be deciding how many number of clusters are making sense. And since K means mean, so the algorithm is based on the mean. Where we have used that mean? Centroid, random centroids are created, then it will be calculating the distance between all data points, and then it will be calculating the mean. So whenever there is a mean, then it will definitely get affected with the outliers. Wherever there is a mean, it will definitely get getting affected with the outliers. In that case, what you have to do? We have to remove those outliers, and then you have to go ahead with K means. Or we will be having the K medoid as well. That is one of the algorithm when it comes to K means category. K means category only, we will be having those. In that case, if you want to go with that, you can go with that as well. And initial centroid position have a strong influence on the result. So you might be seen right in the video how rapidly it will be changing. When you have random centroid, in that case, if you are finding the cluster and we'll be finding the cluster mean, in that case, the first moment will be having high influence. It will the distance, the variance will be high in that case. The very first centroid, initial centroid position have the strong influence on the result because maximum distance it will be covering. Does not cluster well with the cluster of varying size and densities. So various sizes we have, in that case, it won't be able to cluster much. And there is one more we have, let's say 2. This is one cluster and this is one cluster. When you are calculating the centroid, here we have 1 point. When you are calculating centroid, the new centroid, this data coming into this, and if you are calculating the one centroid for this data is coming into this one. So if it is moving, once centroid, centroid is calculated, it will be moving, right? In that case, it is coming into this. And when you are calculating, it is coming into this. So it is fluctuating in between. The data is fluctuating in between these. The data is fluctuating in between these. So in that case, what we can do, we can limit the iterations. We can limit the iteration. So does not cluster well when the cluster is varying size and density. Various size and density when you have, in that case, it won't be cluster well. Infinite loop. So you might run into the infinite loop. To avoid that, we need to give some values, so that if it is exhausting those iterations, in that case, whatever the cluster it belongs to, whatever the data points that belongs to, whatever the cluster the data point belongs to, it will simply stop. So for stability, run Kmeans. So normally when you are taking the data, random data will be taken. Each time if you are running that Kmeans algorithm, each time it will be producing the various other results. For stability, run the K-means clustering multiple times called as iterations with a different randomly chosen K values. This will address the multiple local minima and local maxima. Local minima means when you have this data, two-dimensional data, when you know. So what are the local minima we will be having? It is the local minima and it is the global minima. When you have multi-dimensional data, it is a two-dimensional data, two-dimensional data. When you have multi-dimensional data, you won't be able to say that just by looking at the picture. So you don't know what will be the local minima and local maxima. To address that, we have to run that algorithm again and again. Wherever you are getting the good results and the variance, low variance, in that case, we'll be calling it as good results. So in that case, we might hit the local minima. In that case, we are reducing the errors. So that is the reason, in order to stabilize that, we need to run that algorithm multiple times using the various K values in order to address multiple local minima values. Wherever you are getting the global minima, in that case, we will be getting the least error. Our data point might be keep oscillating, that we have seen, right? That if data point is somewhere here, it might be keep oscillating in between the two. So if it is oscillating in between two, in that case, we will run into infinite loop. We might run into infinite loop. Address this by choosing the convergence criteria. Convergence criteria means each time the centroid is changing to the nucleus, right? That we will be calling it as convergence or iterations. Maximum number of iterations we can simply give. Let's say how many iterations we have taken. Let's say 10 iterations we have taken. Just now we have seen the video, right? Let's say we have taken 10 iterations. In that case, maximum iteration will be taking 20. In that, the whole K-means clustering stability will be happening. If it is not, even though you are running into the infinite loop, it will we have given just 20 iterations, so it will simply stop at the 20th iteration, whichever the data that belongs to. Let's say data point at the 20th iteration, it is belongs to this cluster. In that case, it will become that cluster. If it is belongs to this cluster, in that case, it will become that cluster. That is the reason we will be giving iterations in order to get out of those infinite loops. In order to get out of those infinite loops. So, or we can simply give some conditions saying that convergence criteria should stop when a cluster centroid moves less than certain percentage of the smallest distance between any one of those centroids. So here, when you are forming the various cluster, it will be moving, right? Centroid. So we can give some value. If it is not moving less than this, if it is not moving greater than this, simply stop there. Like that, we can give that condition as well, so that we can avoid the infinite loop. Compare between the cluster variation to the within the cluster variation. So if it is forming these clusters, the distance inside the cluster and distance between the clusters. So whatever the data points inside will be having, we'll be comparing those, and will be the distance between the cluster to cluster, that also we are comparing. Compare between the cluster variation within the cluster variation. Typical objective function used to sum of the square. We will be using sum of the squares of errors in order to find out that, and sum of the squares within the sum of the square, WSS we will be having, that is representing the cluster within the cluster, distance within the cluster, sum of the squares within the sum of the square and between the sum of the square will be having, that is distance between the clusters. Within the sum of the square, it is inside the cluster distance between the sum of the square. So combinedly we'll be calling it as total sum of the square. So that is the error we are talking about. So this is all about the cluster. This is how the cluster will be formed. And this is how clusters will be formed, that is especially when it comes to K-means clustering. So what we'll be doing first, we will be giving upfront K value, and whatever the K value that you're getting, that many centroids will be created. Once the centroid is created, let's say this is a centroid. So whatever the data points will be having, all the data point distance will be calculated. It is also calculated the distance, and then it will form one cluster. It is also forms one cluster, and then based on the mean, whatever the distance will be having it, we will be calculating, and then we will be finding the mean of those clusters. Once mean is calculated, we'll simply shift that mean to new place. Sorry, centroid to the new mean. Similar to that, it is keep happening until and unless it will become stable. If it is having any data points in between, that is having infinite loops, it is getting into the infinite loops. In that case, we'll give number of iterations. Some limitations we will be giving. So it will be doing that many cluster limitations, iterations, and it will simply stop. Like that, it will be happening. So let's see one use case scenario, guys. So here one use case we'll be having, that is use case market segmentation. Market segmentation in SBI life insurance. So since we are talking about the banking and insurance, so we have taken the insurance data. So data summarizes what exactly the data is about. Data set summarizes the usage behavior of about 9,000 active credit card holders during the 6 months of the period of time. So we have data. So what we are doing, whatever the data points we will be having, based on that, we are simply categorizing those customers or credit card holders into various clusters based on what? Usage behavior. So what are the features I will be taking in order to do that? We will go through it. So ask what are the attributes I will be using? Customer ID. So it won't be having much users since it is a nominal data. Balance. So what exactly that balance is, what is it about, what is it is talking about, that we will see in the whole description I'll be having in notebook. So we will be seeing that in a minute. So these are the features I'll be considering. Okay. So these are the features I'm considering. So based on the customer behavior, I have to cluster into various. So what are the Python libraries that I'll be using? What are the tools that I'll be using? So various pandas. Yesterday we have seen why we are using the pandas, and we have NumPy. Why we are using NumPy, that is also we have discussed. Matplotlib. So what exactly the Matplotlib, that is also we have discussed. And then we have SNS, Seaborn package, scikit-learn will be having in order to import the data. So these are the various libraries I'll be using. So that we will be discussing in a minute. So these are the problem statement when it comes to this data based on the details that are given, from the banking. So we'll simply we have to group them into various clusters based on their behavior. So I'm simply looking at whether we have any null values or not. Is the heat map showing that we have a null values or not? Yes. What are the features will be having null values among those? So we have, you can see here, and then I have created the DDA exploratory data analysis. How this credit limit, whatever the customers will be having, their distribution, how good they have credit limit. So is all people are having the same credit limit, or any people that are having less? You can see here, most of the people are having the credit limit in between. Maximum it is 20,000 to 1 lakh. So it is most of the people who are taking the credit card seems like are in the middle. So it is a peak, right? So here about, let's say it is considered as it is 10,000. Okay, it is 10,000. It is in between 0 to 20,000, you can say. Minimum payments, how much payment they have done, what is the minimum payment they have done till now. So that is, so it is about, you can say 5,000 based on that, or you can see credit limit, how much credit limit will be having. So all the description will be saying that, but it is a visualization that we have created in order to do the exploratory data analysis. When you are doing the exploratory data analysis, you will be able to get so many insights, right? Whatever the insight that we are getting, so that will definitely help us out to bring out a better cluster. So which features I have to combine and create a cluster. In that case, you will come to know all those things. So these are the, and then I have find out whether you have outliers or not. If you have an outliers, in that case, we will be removing those. And then we have, a good number of features. So I have simply done the PCA. PCA means principal component analysis. Whatever the features will be having, I'm simply converting into just 2 features in order to do the visualization. So you can easily able to do the visualization. When you have multiple features, it is multi-dimensional data, it is hard to do the visualization. That is the reason I'm avoiding that, and I'm converting that data into the PCA. So how many we have seen, right? So what we have seen, K value upfront, we are giving the K value. So if you are domain expert, in that case, you will be having an idea how much K value I have to give. K is equal to 3 or K is equal to 4. If you have a domain expert, you can simply choose any one of those. But you don't have any domain knowledge. In that case, what do you have to do? We have to do various iterations. Various K values I'll be taking, and then I will be plotting the scree plot. So this is the elbow bar plot, also you can call scree plot or the elbow plot. Why we are using this scree plot and elbow plot? Just to find out how many number of clusters are making sense. K should be how much? So upfront we will be giving random value, K is equal to 3, K is equal to 4, something like that, and then we will be building the machine learning algorithm, and then we will be finding the iterations. We will be tuning, so you can say hyperparameter tuning, similar to the hyperparameter tuning. So here K value I'm considering, and then I'm tuning it. Wherever I'm getting the good results, whichever the cluster, whichever the value, K value, whichever the K value that you are getting, you can simply take that K value as the best K value. So here I have used iterations. So wherever, so it is a elbow plot, wherever it is looking like elbow, wherever it is looking like elbow, you can see similar here, it will be looking like elbow, right? Looking like elbow. So that place you can consider as the best cluster. So here K is equal to 4 are the best cluster. Or It is not always, it won't happen the exact, elbow place only will be giving the good results. In that case, you can nearby values you can check, and you can check the variance. You can check the variance of those clusters. So wherever you are getting the least variance, you can simply consider that k value. K value is the best value. So like that, when you don't know or you don't have a domain knowledge, we will be coming up with tree plot, or you can also call it as a elbow plot to decide how many clusters are making sense in your data. So it is a tree plot, elbow plot. You can see the final visualizations. How many number of clusters I have considered? 4. So cluster 1, cluster 2, cluster 3, and cluster 4. So we have blue cluster, what exactly it is representing, and we have green cluster, what exactly it is representing. We'll see while we are doing the program. So this is how you will be getting the final cluster. Since it is having multiple features, in that case you can see it is multi-dimensional. If you want to move it, if you change this axis, in that case you can easily able to see those. So here we have created the PCA and PC1 cluster. PCA means what is principal component analysis we will be doing. Whatever the number of dimensions will be having, how many dimensions we have here. How many features we have here? Customer ID, we are not taking 1, 2, 3, 5, 6, 7, 8. 8 features we have. So those 8 features, what we are taking, we are simply considering, we are converting into PCAs. So now 8 features become just 2. Those are PC1 and PCA2. Principal component analysis 1, principal component analysis 2. So like that, we will simply creating or transforming the data into components. So here we are simply deducting or reducing those features. Dimension reduction, that is the reason it will be called as dimension reduction. So what kind of inferences we'll be getting? We'll see that credit card that offers credit insurance provider. So very first cluster, what it is talking about. So you can see cluster 2, cluster 3. So these are the variants. You can observe the difference between all these things. 309, it is one of the purchase. So what exactly the description, we will go through it. But what are the inferences that you are getting? So here you can see credit card that offers credit insurance provides a waiver. So whichever the credit card is providing the insurance, it will provide a waiver of outstanding credit card bill payments in case of accidental death or cardholder. Let's say we'll be getting that inference. So if you are having credit card insurance and you have outstanding payment to do, and unfortunately some death happened of that particular customer, in that case who will be paying that amount? So credit card company will be paying that particular amount. Credit card insurance plan offers a financial protection to the cardholder in case of unforeseen event where the cardholder is unable to repay the credit card bills due to the loss of income or disability, injury, or death. Same, but it will be adding a few more. So instead of if he is doing some business, in that case he lost everything. In that case also, it will be the bank will be providing the if you have high insurance, in that case it will be providing the protection. So we'll see the coding and we'll try to understand how we can do the Kmeans algorithm. Yeah, so this is the code we'll be having. Let me add the data again. Yeah, customer, copy the path. Yeah, I think it is the exact same path. I've uploaded, but it is gone. So first we will see what exactly the business objective is and what is the, so maximize. So based on the data, what we are supposed to do is maximize the insurance sales by analyzing the customer credit card information by segmenting method to design a new insurance product. So if you are going through that, in that case, you will come across some inferences. In that case, we can increase, in order to increase the sales, whatever the inferences that you will be getting, you can marketize that. Maximize the inference sales by analyzing the customer credit card information. When you analyze that, you will be come across so many inferences, right? So they same will be using, and whatever the customers will be having, whom, I mean, those people we are simply clustering into various clusters, various groups. So minimum access credit card. I mean, what is the constraint when it comes to this? Minimum amount of data that is available. So in that case, it is one. Data description. So these are the features we will be having. Balance. So what is the description for this? The balance amount left in their account to make a purchase. How much data, how much balances you are having right now? Balance frequency, how frequently the balance is updated, how frequently you are adding the balance into your account. So if it is very frequently, in that case we'll be saying 1, and if it is not, in that case we are saying. It is also one important feature, right? Purchase, amount of the purchase made from the, how much amount of the purchase that you have made from that particular account, credit card account. Maximum purchase amount done in one go. So what is the maximum amount that you have spent on one particular product? Like 10,000, just single product, how much amount you have spent? And then we'll be having amount of purchase done on installment. So how much money, like whether you have taken the 1 lakh product, for that installment you have taken, or it is 2 lakhs product, for that you have taken installment, or just 10,000 products, for that you have taken installment. So that is also one important factor. Cash advance. So how much advance cash, for that particular product you have given. Purchase frequency. How frequently the purchase are being made. So if you are purchasing the products are very frequently, in that case we can come up with various other inferences. If we not, in that case we might be coming up with other inferences. One of the purchase. How frequently purchases are happening? Very frequently, in that case 1, if it is not, in that case 0. And cash advance frequency. How frequently the cash in advance being paid? How many times that you are paying the money in advance? Number of transactions made with the cash in advance. How many number of transactions that you are made with cash in advance? For that we will be having the data. So like that we have various, and here you can see purchase, number of purchase transaction made, and limit of the credit card data for the user, and amount of payment done by user, minimum amount of payments made by the user. So these are the various descriptions. If you want to, you can simply go through it. And then we need to have a library set in order to perform that operations. So pandas, numpys, pandas for what? In order to do any manipulation in your data, in that case, I'll be using the pandas. And numpy, if you want to do any mathematical operations, in that case, I'll be using numpy. Matplotlib for the visualization, cborn for the visualization, standard scaler. So we have various, yesterday we have seen, right, standardization and normalization. Yesterday we have seen, right, standardization and normalization. When we will be using this, when you have a data frame, and the input scale of inputs are very different. X, Y, X1, X2, X3, something like that. Here we have just 0.1 to 1, that is the range. 1000 to 7000, that is the range. 120, 152 to 70, something like that. This is the range. In that case, various ranges will be having it. To make the data scale free, we will be using the standard scalar. So for that, I need that library, standard scalar library. And PCA, whatever the columns I'll be having, I'm decomposing into just two. In that case, I'll be using that. And these are the algorithms. Kmeans, agglomerative clustering, DB scan, density based scan, and spectral clustering. So various clustering techniques I'll be using. Among those, which one is performing best? That also I'll be looking at it. Gaussian mixture I'll be having chill out. So it is whatever the data that whatever the clustering that you are doing, how good those clusters are. It is a evaluation techniques, you can say. It is a evaluation technique. So I'm loading that. It is loaded, and then I'm loading the data frame. So these are the data frames, and these are the features we will be having. And the very first we will be doing the. So you can see as credit card shape. So how many number of features we have? 18 features. And how many number of entries we will be having? 8,950. So when you have a shape, this is, and I'm doing the credit card info. I'm running credit card info. What it exactly it will do? It will simply go through it. How many null values will be having? Null values are not available values. So overall entries we have 8,950, 8,950, and the rest, if you have less than that, in that case we will be having some null value. You can see here 8,949 means we have some null values. 8,950 no null values. Here we have null values. Here we don't have. Here we don't have. So where exactly I have null values and how many? So I'll be doing that as well. So null values. So you can see these are the null values here and here and here. So you can see these are the null values that are present. Null values. So how we will be removing that? We'll simply drop it. And we'll be finding out all the features that are having. We can simply see here credit limit and the minimum payment. Among those 9,000, we just have one null values. You can simply drop it, that particular whole feature. You don't need to do the imputation for that. Or if you want to do the imputation, in that case, you can go ahead with that as well. So minimum. So among that, just 303. It's very small amount. So if you want to remove it, the data, whole data, you can remove it. Or if you want to go through imputation techniques, in that case, you can go with that as well. So, and we have data, right? So numeric data will be having. So, and then what we will be doing, whether numeric data, whatever the numeric data we will be having, whether it is symmetrical or not, having normal distribution or not. So credit limit I'm checking. See, here it is not a normal distribution. It is a right skew. So it is a minimum player payments. It is also a right skew. So I'm simply checking whether we have any normal distribution or not. So it is not a normal distribution. When you don't have a normal distribution, what you are supposed to do? When you don't have a normal distribution, we have to convert that normal distribution or non-normal distribution to normal distribution. For that, we have various transformation techniques. So normal distribution, I'm going to. Okay. So no issues. Yeah, distribution, whether it is normal or not, credit limit I'm looking into. So this is also not normal. So we have a null values, and in that we have any normal distribution, that is we are checking. So all data seems like it is a skew one. And then what I'm doing, I'm simply removing, or you can simply replace. Here I'm doing, even though it is just one, I'm replacing with the mean data. And once the replacement is done, I'm checking whether we have any values or not. See, it is, we don't have any NA values. We have 300 something and one, right? So those have been replaced. Minimum payment and credit limit. In that we have null values or not available values, or that those have been replaced. And I'm checking whether we have any duplicate data or not. So we don't have any duplicate data. And here, customer ID. So it is a nominal data. It won't be giving you any information. If it is not giving any information, what we will be doing, we'll simply drop those. So here I'm simply dropping that particular feature. So it is not more. And you can check now, right after dropping, you won't be finding that customer ID into this data. So, and again, I'm checking the probability distributions. If you want to go with all at once, in that case, go with it. So the distribution we are checking of all the features, various features will be having, right? Whether it is normal or not. So we are checking, seems like the data is, all the data are skewed, right skewed. Now it is left skewed. And then we have to go with the outlier detection. So outlier data, we have any outlier data in your features or not. So how much, if we have, how much percentage of data is having the outliers? So I'm checking that. You can see 10% in balance. I have 10% of data is outliers. Balance frequently it is 75% data, 27% data, 53% of data. So what we will be doing, whatever the data that we will be having, remove the outliers. If you are having less than, if you have 10%, nearly 10%, in that case, I'll try to remove those things. So I'll be removing those features, and the rest, whatever they will be having, I'm simply replacing with the quantile values, upper quantile values, remove outliers from columns having nearly 10% of outliers. If you have just 10% of outliers, in that case, you can simply remove it and you can go with the analysis. If it is more than that, in that case, you can go with the replacement techniques will be having it, vinsurization. You can go with that. So now the data we will be having without any outliers. And now I will be finding out the correlation. Correlation means how each data is related. So all the features we will be having here. So balance, and is balance, and the balance frequency, and it is a balance frequency. So this, we have a diagonal. It is itself, and data and itself, how much correlation we have. How much correlation we will be having. So itself, it will be having 100% correlation, right? If this is the diagonal data itself, so we have to ignore that, and rest we have to find out where exactly we will be having. So if it is white color, in that case we will be having less, that is minus, or you can simply say less correlation will be having, as it is increasing with dark purple color. If you have, in that case, it is having the highest correlation. You can see here 86. It will be having, so both are same only. So purchase 86 and purchase. Purchase and what? Let me. One of purchases plus purchases. So it is having good, correlation. Yeah, obviously one of the purchases and purchases is having a good correlation. And then let me drag this. Here you can see 81 for what? Cache advance and cache advance frequency. So similar data will be having. That is the reason it is showing the good correlation. So once it is find out the good correlation, in that case we will be doing the scale data. So whatever the data that is not having good variance or various, I mean very different ranges we have, in that case we can simply do standard scalar. So what we will be doing is, in on standard scalar we will be bringing down the various scale data into just one, making the data scale free. So we have done data scale free and dimension reduction technique. So whatever the data that we will be having, I'm simply converting into PC1 and PC2 so that I can make that visualizations very clear. So you can see that PCA head. So we'll be getting this, and then I'll be finding out the K value. You can see K value. So in order to do the K value, you will be using inertia, that is the variance. So using that variance, I'll be taking K values that is ranging from 1 to 15, and we'll check how the spread is there. So here 4, 5 and 3, you can try those. Wherever you are getting the least variance, that we will be considering as best cluster. So from this, I'll be selecting like 4, 5, 6, and you can do multiple iteration. So various clustering techniques will be having here: spectral and agglomerative and Gaussian mixture model based clustering also. And whatever the final clusters will be having, you can find out those scores here. You can see Similarity scores. So agglomerative clustering, how much score we'll be having. Based on that, we can decide which one will be giving the best accuracy. Here I'm focusing on Kmeans clustering, guys. So among those, Kmeans will be giving the best accuracy or best cluster. So I'll be going with. So how much I'm giving? 4 clusters. So on which data I'm applying the PCA, principal component analysis data will be having, right? I'm simply applying on that only. And then I'll be creating the visualization of scatter plot. So finally, you will be getting these cluster. So based on K value is equal to 4. Yeah, K value will be having 4. You can see 0, 1, 2, 3. The final segregation, it is nicely done, right? So this is a segregation we'll be having. It is one cluster, and it is one more cluster, and it is one more cluster. So like that, whatever the customer behavior will be having, we have found out already in the inferences, right? So these are the clusters, various clusters. If you want to go with agglomerative, in that case, you can go with the agglomerative, right? So you can see the cluster, whatever the cluster that you have got here, it won't be having that many good clusters. So it will be performing well. And you can see with other spectral clustering as well. So it is not doing great. DB-SUM cluster as well. So various clusters will be having. Among those, Kmeans will be performing the best. Find the best clustering technique. Based on what you will be doing the silhouette score to find out that. And these are the clusters. The cluster 1 and cluster 2, cluster 3 and cluster 4. And we are simply saving the model, and you can simply submit this to your client. And by saying that, so these are the customer data that you have given, and these kind of clusters we can form using that particular data. So yeah, this is all about the Kmeans clustering, guys. I hope you guys have learned something. It is market segmentation for life insurance analysis using the customer credit care data. So we have a very limited data, guys. So in that case, we won't be replicate this into replicate deployment. We need to have large amount of data, so that whatever the inferences that we are getting, it will be on pinpoint. So we need more data, but you can consider this as a base model. So this is all about the Kmeans clustering. It is about the K-means clustering under unsupervised learning. Unsupervised. So we'll get back to the And yeah, that is it for today, guys. I hope you have learned something. If you want to see more of videos, something like this, you can continue this series. Since we will be dealing with more such algorithms. Today we have discussed about supervised, unsupervised. And next class we will be discussing with supervised. So what are the data we'll be what are the algorithms we will be having when it comes to supervised? We'll be taking one by one algorithms and then we'll be using one use case scenario. Use case. We'll be taking one use case and we'll try to implement that in that particular algorithm. So like that we will be continuing this series. And when it comes to, of course, banking and insurance. Banking and insurance data we will be taking in that only we'll be taking the use cases and we'll try to bring out the inferences. And if you want to kickstart your data science careers, guys, Python is compulsory in order to learn data science. So if you want to learn the Python, you can simply go to YouTube and you can search Tame Python by Bernie. And there you will be finding the playlist of those Python. All those videos are free. In that case, you can go through it. And yeah, thank you for joining, guys. And we'll see you in the next class. Until then, have a nice day. Yeah, if you want, you can simply join these links as well. These are the 360DigiTMG link. If you want additional information, you can simply visit those links.